Students, lastly we have read about the laws of refraction and the second law, which is also known as the Snell's law, which is very much important. And finally, what we got from the Snell's law, we got that sine I by sine r, that's the constant, and that very constant gives us the refractive index of the medium. Now what is this very refractive index medium? Refractive index, the index of refraction. Index of refraction or refractive index of medium tells us how much the ray of light gets bent in that very medium. That when a ray of light goes from one medium to another medium, we are having two media here. This is the interface, this is the separation between two media. This is the ray of light obliquely incidented on the surface, and at this very point of incidence, if it's a rarer medium and it's a denser medium, the ray of light once it touches here, it will go like this. So how much this angle of refraction, this angle of incidence, how much ray of light is refracted as it goes from one medium to another medium, how much bending takes place away from normal or towards the normal, that gives us the refractive index of a medium. And if a medium is having more and more refractive index, that means the speed of light in that very medium is very much small. So refraction index actually is how much the light bends in a medium, and it has been defined as this refractive index. It is defined as the ratio of speed of light in vacuum oblique air, because almost vacuum air it's taken same, to speed in a medium. Defined as the ratio of speed of light in vacuum or air to speed of light in medium. So we can give it is denoted by either n or oblique mu. You can denote by mu equals to what? C over V. Well, what is C? C is the speed of light in vacuum, and V is the speed of light in medium. So if we have to find the refractive index of medium, we'll take the speed of light in vacuum, that's 3 into 10 power 8, which is always given there, 3 into 10 power 8 meter per second. And if it is given in the question that how much speed the light is having in a given medium, then we can calculate how much the ray of light is going to make. This COV, this is called as the refraction index, as it is a division between two similar quantities, speed, and it is also speed. The unit here is meter per second, the unit here is meter per second. So mu is what? It is unitless. Dimensionless. Unitless as well as dimension. So mu is having no units and no dimensions, as it is the ratio between two similar quantities. Mm. So as mu is having no units, it is a unitless dimensionless quantity. Now this very refractive index is also called as absolute refractive index. When a ray of light goes from, what is absolute? There are two refractive, absolute refractive index and relative. What is absolute refractive index? Absolute refractive index means when a ray of light goes from vacuum to any medium or air to any medium. That's called as the absolute refractive index of that very medium. When ray of light goes from vacuum oblique air to any medium is called as absolute refractive index. That means if a ray of light goes from vacuum to glass, that will be the absolute refractive index of glass. If a ray of light goes from vacuum to water, that will be absolute refractive index of what? Water. That's how much the ray of light bends when the ray of light goes from vacuum to water. That will be absolute. Now we are having another refractive index. If we are having media, if we are having now two media, if we are having now water and glass, what I mean, so we have to talk now relative refractive index. Relative refractive index. Relative refractive index, you have to suppose, let this be now water and this be now glass. Now ray of light, water is itself a medium, glass is itself a medium. Now when the ray of light goes from water to glass, the ray bends. How much this ray bends as compared to the ray when it is traveling in water? That is called as the relative refractive index of glass with respect to what? With respect to the water. So if we are saying this very medium, if in it we are having a speed of v1, because you will not know c is the speed of light in vacuum. Now we will have the speed of light in water, some v1, and we'll be having some speed of light in glass, that will be v2. If we are going to find here refractive index, that will be mu. This is medium first, this is medium second. This will be refractive index of second medium with respect to first, like this, mu 2 1. Refractive index of second medium with respect to first. Once we are going to write it like this, it will be simply v1 by v2. In the first case, when it was absolute, then we put mu equal to simply c over v, because there we were having the light coming from air or vacuum, and in a particular medium, that was absolute. Now we are having light, ray of light going from one medium to another medium. Those are totally different media. So here mu1 2, the relative refractive index of what? Second medium with respect to first. That you have to read. Relative refractive index of second medium with respect to first. Okay. So relative refractive of second medium with respect to first. It is it is written as like this. It is 2 1. Refractive index of second medium 2 1 2 1 2 1. Refractive index of, or sometimes we can write it like this, mu 2 here, 1 here. Refractive index of second medium with respect to first. That means how much the ray of light is going to bend in second medium as compared to first. It will be v1 over v2. Moreover, it will be having some absolute refractive index. Let that be n1. And it will be having also absolute refractive index. Let that be n2. If this very equation is first, we'll put like this, v2, or like this, c over v2 or c over v1. This is your equation, because on solving it we will get v1 by v2. Now this c over v2, it will be simply n2 or mu2. Mu will place it because we have used the notation mu. It will be here mu2, it will be here mu1. So thus mu21 relative refractive index of second with respect to first is equal to mu2 by mu1, mu2 by mu1. That is the ratio of absolute refractive index of second medium with respect to the first medium. That uses the relative refractive index of second medium with respect to the first. So this was related to refractive index. Also the relative refractive index doesn't have any type of units, or you can, from the Snell's law, we were having sine I by sine r. If we have to write it down here, sine I by sine r equals to what? That will be simply mu2 by mu1, because now sine I by sine r gives us the relative refractive index, that is mu 2 1. Refractive index of second with respect to first equals to what? Mu2 over mu1, which implies what we'll get from here is mu1 sine I is equal to mu2 sine of r. This is very much important equation. We will read for this very equation, what is its importance in the coming lectures. Tomorrow will be with another lecture related to refractive index. Till then, Allah Hafiz.